All right, good morning. Okay, first of all, I did get a message from the principal saying that it is windy today. And so I do understand about internet issues when it's windy, okay? But on regular days, I expect your devices to be working. We've been in school since August. I expect your audio to be working and I expect your video to be working. If your devices are not working, it's your responsibility to go to the school and either get a new device or call the school or district to get your problems straightened out. For example, the problems we've been having with the glitching, I've been thinking and thinking, what is it? And I think I figured it out and I'm going to get it straightened out today. So that's what I need you. You guys are 11th and 12th graders. I need you to take responsibility and have your devices working. All right. Those of you who can't get into the teams, you're not allowed to just go to any team you want. You have to go to the teams because I'm the leader. You're following the leader. You're going to the teams that I provided. Otherwise, you're messing me up. So I hope I'm making myself clear. You need to follow the leader. You need to have your devices working. If they're not working, get them working immediately. All right. Be responsible and take care of business. Like I said before, and I have to keep saying this over and over again, we waste so much time me talking about this. I have not changed anything from last semester as far as the Math Wizard teams go. So if you're doing something different, like trying to get on from your phone, or you're trying to go some other way, that's why you're having problems. You have to make sure that you're trying to join the teams using your school account. If you're trying to maneuver it some other way, that's the issue. It does not recognize your personal account, and that's what's happening. So get it straightened out. All right, now, yesterday was very enlightening to me, and so I'm going to break everything down. I know this assignment is due tonight. I was going to teach a new lesson on logarithms, but I can't because you don't know what's going on, and so I'm going to take a day to do this. And it's crazy because I taught this lesson on Monday and now it's Thursday and we still don't know what we're doing. So, I don't know, it's very frustrating to me. If we went at this pace all the time, we would never get through. We're only in chapter 2. We're supposed to be like in chapter 6. You know what I mean? It's crazy right now. So, anyhow, please open up your books to page 448. All right, on page 448, we looked at problems 1 through 10 yesterday in evaluating exponents. So hopefully you can put it on the calculator and you can round to the third place to the right of the decimal. Is there anybody who needs me to, because here's the opportunity, we really need to break it down now. And I need you guys to be very candid with me and let me know what you don't understand because I'm taking time now. Anybody need me to go over problems 1 through 10? Are you able to put it in the calculator and get the right answer? All right, 11 through 18, we're looking at the and I'm going to go over how I do this. And I'm going to break it all the way down to the nuts and bolts. Let me check myself real quick. So I'm going to pick a problem and show you what I'm doing. So for example, in problem number 11. All right, what I'm doing is I'm making an input-output table. So I'm inputting an x, and you can pick any x you want, or output fy is f of x. So I like to pick 0. So what I'm doing is I'm putting 4 to the 0, which is 1. And that's how I'm getting the ordered pairs 0 up 1. So you haven't seen me do this work because I thought you could do it, but I'm finding out that nobody knows what I'm doing. When you put a 1 in for x, you get 4 to the 1, which is 4. So this is the ordered pair, right 1 up 4. So that's how I'm getting the parent points. Do you understand what I'm doing? Okay, can I erase?
Yeah.
Something? The parent, you see me write this, but that's what I'm doing in my head, is that table. Now, when this number is a number, like a whole number, it's exponential growth. So, and whenever you don't have a K, your horizontal asymptote is just 0. Now I'm going to break it down even further than this, but I just wanted to show you this problem. All right, so we have, I hope you're writing it down. So we have a horizontal asymptote at y equals 0. And that's a line. And we draw the point 0 up 1 and right 1 up 4. And we draw a graph that looks like this, and you draw the graph without hitting the asymptote. You draw it along the asymptote and up. Now, as far as the domain goes, if they ask you for the domain is where the graph exists left and right. So the domain would be negative infinity to infinity, forever left and right. Here.
From 0 to infinity.
Yes, thank you. Because it doesn't hit the asymptote, so don't close it. Okay, now okay, anybody have any questions about this? I'm gonna break it all the way down. All right. All right. The California Common Core State Standard says that students will know what A, B, H, and K do to a graph. So let me show you the equation. So you're supposed to know what A, B, H, and K do to a graph. And this is very, very important because we have 15 functions. The cube root, the cubic, we have the quartic, we have the logarithm, we have the exponential functions. I mean, there's a whole bunch. So if you know how to do one of these, you should be able to do all of them because they're showing up all the time. So that Z right there is the parent. So we're not. Make sure you write it. What does A do to the graph? So when something's being multiplied, what does it do? Anybody know? It's a vertical stretch or compression. So that means that if a stretch means you're going to pull the graph up, a compression means you're going to push it down. So it's a stretch. If those numbers are 2, 4, 5, numbers like that, it's a stretch. If it's a proper fraction like 1/2, 2/3, 4/7, 5/9, it's a compression. And it can't be negative, by the way, because the negative means that it's a reflection over the x-axis. So these are vertical stretches, and if it's negative, it's a reflect over x. So this cannot be negative. So if you see something like this, that is not z. What that means is -1 times 2 to the z, because that parent cannot be negative. A negative is A. So now we look at B. B is a horizontal stretch of compression. And you have to take the reciprocal of B. So if you see 1/2, 2/3, 4/7, that is a horizontal stretch because you have to take the reciprocal. The compressions look like this. Because once again, you have to take the reciprocal, those would be compressions. And if your B is up here, B's up here, if your B is negative, it's a reflection over the y-axis. So A reflects like this. So you have to negate the y if it's A negative. If it's B negative, you have to reflect it over the y, which is a horizontal, which means negate the x. H moves the graph left or right. K moves the graph up or down. Now, you guys, I cannot remember this for you, and I'm not going to give it to you again. I'm over it. I gave this to you. I expect you to know it or write it down, tattoo it on your arm or something. You also have to know the order if there's multiple transformations. So the order, the first thing you do are left and right. And that has to do with H. The second thing you do are stretches and compressions. And that has to do with A and B. The third thing has to do with negative A or negative B, and those are reflections. And the last done is K, which is up or down. So make sure you have this stuff written down, because we're going to do a read on you. So you have to know what A, B, H, and K do. Now, one thing about the exponentials is that you should know that B and H are in the power. A and K are down below. Can I erase this?
Yeah.
All right, so let's just practice and make sure we know what's going on. Somebody mute yourself, or I'm going to call on you. Somebody unmute yourself and tell me, what is this? I want you to tell me, is this A, B, H, or K? And then tell me what it does. And you're going to look at your notes. Is this A, B, H, or K? And what does it do? Go ahead, anybody.
That's K.
Yep, it's K.
That goes up.
Yes,
goes
up 4. Good. Good, good. All right, I'm just going to keep going on like this for a little while. Now, before you answer this one, we know that this minus is part of the form. So we're not looking at the minus. This is not -4. This is a 4. The negative is part of the forms. All right, so somebody tell me, is this?
It's H.
Yep. And what does it do?
Left one.
Okay, so remember the negative is part of the form. So is 4 left or right?
Right.
Right 4. And you guys, I can't remember this for you. You have to remember it. Negative is part of the form, right 4. You can't mess it up. You're going to be getting a lot of problems wrong. 15 functions you're going to get wrong. All right. Now remember, if this has to be a negative, this really, you're seeing this is what you're really seeing. X plus 4 means X plus 4. So once again, this is H, right? What does this say?
Left 4.
Left 4. Now, let me just tell you this. When you go left, right, up, and down, you don't change the graph. All you're doing is moving the graph around, and that's called a translation. So when you do translations, you're adding and subtracting. So adding and subtracting does not change the graph. It just moves it around. When you stretch or compress, you are changing the shape of the graph. You are morphing the graph, and you have to multiply sides Victor. Is this A, B, H, or K?
A.
It's A. And what does A do? What is this thing? Is this a, it's a vertical what?
Vertical stretch.
It's a vertical stretch by 2, right? And this means that it's being stretched by 2. Notice how I'm changing the parents, but we don't even care. I could change the parent. Now, let me tell you something else. The parent is always the exponent. So whatever the base of the exponent is, that's the parent. And he has nothing to do with these stretches and compressions and everything else. All we care about is A, B, H, and K. A, B, H, or K? Jerry, are you out there, Jerry? Jerry? No. Andres, are you out there? No.
Yeah.
Okay, Andres, is this, what is this thing? A, B, H, or K?
Is it A?
Yeah. Uh-huh. And this is a fraction, so it's going to be a stretch. It's going to be a compression by 1/3. All right. So what do you think about this one? Is that A, B, H, or K? Angel out there? Is this A, B, H, or K? Angel, are you there? Is that A, B, H, or K? Murray, somebody? Cynthia, you're out there. Jaden, H or K? Somebody? Naomi, Paige? Anybody?
Is it A?
It's A. Yeah, it's A. Yeah. And what does the negative mean? Reflect, right? So what does that mean? Reflect, X or Y?
X.
Yeah, and it means this. You're going to reflect it over the X, which is a vertical movement, which means you're going to negate the Y. Okay, and what about, can you guys see this? One more, f of X is equal to 4 to the negative X. So that's also a reflection, right? And isn't that B?
Yeah.
So you're going to reflect what?
The y.
Yep. So that means what? So reflection over the x, you negate the y. So that means make the y negative. And when you reflect over the y, you make the x negative. All right. Does that help?
Yeah.
Okay. So once again, I'm going to model a problem, and then you're going to go into your pairs that I picked, and you're going to graph. And so I'm going to do problem number 30, and I'm going to follow the right order. I'm on page 448, number 30. The parent is 2 to the x, and you have plus 2 minus 1. So this is showing exponential growth, so I always draw a little picture. And I'm going to write down the transformation in the correct order, which that has to be a negative. So that's left 2, down 1, right? Because isn't this x minus a negative 2?
Yes.
So my parent points, I'm going to make that table in my head. What's 2 to the 0?
1,
What's 2 to the 1?
2.
And we know that the parent has a that ask they ask actually not in these problems. They don't ask for the parent on this. They ask you to make a table. We're not making a table. I'm doing problems 25 through 34. Okay, I'm doing problems 25 through 34. So here we go. All right, so the parent would be 0 up 1 and right 1 up 2. And we have a horizontal asymptote at y equals 0. So you draw it like that. And they ask for the domain in the range. Where does the graph exist left and right?
Negative infinity to positive infinity.
Yep, good job. Okay, where does the graph exist up and down? Where does it start existing?
From 0 to infinity.
Yeah, good. 0 up forever. Good, 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 good. All right, now I'm going to do the next part in orange. So this next part says left, which just means move the graph. So I'm going to subtract 2 from the x. And I'm going to subtract 2 from the x. And now down 1 means subtract 1 from the y, subtract 1 from the y, and now we graph those. Left 2, 0, left 1, up 1, and we have a new asymptote, because who moves the asymptote? A, B, H, or K? Who moves the asymptote?
A.
Okay.
K, right. So we have y equals negative 1. So we're going to draw our asymptote at y equals negative 1. We're going to draw our graph along the asymptote. And now what's the domain and range of this guy? So don't look at the black graph. We're only looking at the orange graph. So what's the domain?
Negative infinity to positive infinity.
Good. What's the range?
Negative 1 to infinity.
Good. Got it. Good job. All right, now, if I give you a problem Can you get the parent points in asymptote and get the new graph points in asymptote and state the domain and range? Can anybody want to ask me about it? This is what I want you to do.
I think I got it.
You got it? Okay. Anybody else have a question? Okay, here's what I want you to do.
Is Verge
Yeah,
for the -1, so that's gonna be the horizontal asymptote.
yeah, the K. Right, the K is always the horizontal. So if this said +6, this is going to be y is equal to 6. If this is negative 11, it's going to be y is equal to negative 11. So whatever this K is going to be your new asymptote. So it's K that, watch my arm. It's the K that's going to move the. Does that help? Jerry, does that help?
I got it. Thank you.
Okay. All right. Anybody else want to ask me about anything? Okay. So who moves the asymptote? A, B, H, or K? Class?
Okay.
Okay.
Right. Got it. All right. So you're going to go into your pairs. And I'm going to tell you what I told first period. You're going to get no help with the second semester final if you don't show your video and work together. So I'm not going to keep reminding you every week. You have to show your video. You have to work together if you want help with the final at the end. Otherwise, I'm just going to give the final and see how it goes. Now, like I said, I do realize the wind's blowing today, so I'm going to be a little lenient. But in the future, when the wind's not blowing, I expect you to show your video. I expect your audio to be working, and I expect you to get these problems resolved. All right, here we go. We're going to do problem number, you're going to do 11:18. You're going to come back here at 11:23. You have 5 minutes. All right, I'll see you back here at 11:23, back here in WebEx. So you're going to go to your Math Wizard teams now. Hi, guys. Did you make it back? Hello?
Yeah.
Guys back?
Yeah.
Yeah.
Okay. Now, I'm not going to go through the whole problem. I'm kind of just giving you a snapshot. All right, here we go. For number 29, who did you get for the parent? Okay, we got to do this quickly. What points did you get for the parent?
0, 1,
And what was the other one?
1, 2.
Okay. And the asymptote was y equals 0, right? Okay, who got that right? Unmute yourself. Who got that right?
I did.
Okay.
I did.
Anybody else? Okay, good. Anybody else get it right?
I did.
I did.
Okay, all right. So we graph y equals 0, and number 29 is exponential growth. All right, so we graph 0 up 1, right 1 up 2, and we draw the graph. Okay, somebody tell me, what did you get for the domain?
Negative infinity to infinity.
Okay, what'd you get for the range?
0 to infinity.
Good, Andres. All right, so let's do we're not going to do the point transformation. You're just going to tell me, what did you get for the new points and the new asymptote?
-1, 0 and 0, 1.
Okay, and -1, 0. And then what'd you get for the asymptote?
-1.
Okay, thank you. All right, so we're going to draw the asymptote. And I appreciate that. You guys had me on edge there for a minute the last couple days. So, all right, 0 up 1. Oh, yeah. 0 up 1, and then we have left 1, 0. And you're going to draw the graph along the asymptote. Okay, don't look at the black graph. Don't look at the black graph. What's the domain and range?
Negative infinity to infinity.
Range.
Negative 1 to infinity.
Good. All right, good job. All right, give yourself a hand. Give yourself a hand, everybody. Come on now, give yourself a hand. All right, ready for another one? All right, let's try another one. All right, what I'd like you guys to do right now is I want you to do problem number 31. So you're going to do problem number 31 back to me at 11:32. All right, number 31. See you back here at 11:32. And we're back. Are you guys there?
Yeah.
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 Okay, check this out. Check this out. A lot of people think that this is like a vertical stretch. It's not. That's the parent. So remember that the parent is the most basic graph. So this is just a reflection over x. And this is exponential growth. And if we did the parent points, you got 0 up 1, right 1 up 2, and there's nothing to do except, watch my arm. When you reflect over x, you negate the y, right? So this would be 0, negative 1, right 1, down 2. All right, and our asymptote is y equals 0, and our new asymptote didn't change because there was no k. Can you guys unmute yourself and tell me if you understand or not? I want everybody to unmute yourself and tell me. You get it or not?
Yeah, I understand.
Yeah, I understand.
Yeah. Okay. All right, so when we graph the parent, we have a horizontal asymptote at y equals 0. And we're graphing 0 up 1, right 1 up 2. And sometimes people draw the graph like that. Don't do that. You have to run the graph along the asymptote. So don't hit it, but run the graph along the asymptote and up. All right, so what's the domain, guys? Where does the graph exist left and right? What's the domain?
Negative infinity to positive infinity.
Okay, and what's the range?
0 to infinity.
Yeah. All right. So now we go to the orange graph. We have the same asymptote. Yeah, okay, now listen to this little picture though. When you reflect over the x, isn't this graph going to look like that now? If you So we're going to go 0 down 1, and we're going to go right 1 down 2. And it's like, hold on, what are we doing? You're reflecting it over the x, right?
Yes.
Okay, so what's the domain and range? It's still forever left and right, but what about the range?
0 to negative infinity.
Yeah, but you're going to watch how you write it. It's going to be negative infinity up to 0. Because remember, the small numbers in an interval have to go on the left, and the big numbers go on the right. So since 0 is bigger than negative infinity, you have to put negative infinity on the left and 0 on the right. Right?
Yes.
Yep.
All right. So let's try another problem. Do you guys remember the E number?
Yeah.
Okay. Let me do a problem first. So I'm going to do problem number 38. So problem number 38 says g of x is equal to the e to the x minus 1. Well, we know that e is 2.7, so we know this is exponential growth. Is this A, B, H, or K?
Okay.
Right. So that's going to be down 1. And over here, our most basic graph of the parent is just e to the x, right? So what are our points? When you put in a 0, what's e to the 0?
1.
Yep. And we put in a 1, we get e to the 1, right? Well, we know that e is 2.7, correct? And our asymptote is still y equals 0. Okay, ready? When you move down, 1 minus 1 is 0. Confused, it's going to be 7. Or hold on, is that right? No, it's not 1 minus 2. It's, this one is 1 minus 1, and this should be 2.7 minus 1, right? Is that right? 2.7 minus 1?
Yeah.
You guys with me or no?
Yeah.
Yeah.
And remember, we have to line up the decimals. So when you line it up, you're not putting the 1 over there, you're putting -1 minus 1.0, which would be 1.7. You see what I did?
Yeah.
So E minus 1 is 2.7 minus 1. Line up the decimals. And now, do we have a new asymptote or not?
Yes.
What is it? Y equals what?
-1.
Right. All right, so come over here. We're going to graph y equals 0 for our parent. And we have the points 0, up 1, and right 1. This is right 1, up 2, and 7/10. So it's almost 3. So right 1, almost 3, 2.7. And we're going to draw the parent along the asymptote. What's the domain and range of the parent?
Negative infinity to infinity.
Okay, and
0 to infinity.
good. It's good, Andres. I think that's you. All right. Okay, now, so these are our new points. We have a new asymptote at y equals -1. We have the points 0, 0, and right 1, right 1 almost 1 and 7/10 is about 2. So right 1 of about 2, 1.7. You're going to run your graph along the asymptote. All right, what's the domain of your new graph?
-infinity to +infinity.
Good. What's the range?
-1 to +infinity.
Good, Jerry. Good job, guys. You guys are doing so much better today. Thank you so much for making my day, because I was really frustrated. Yeah, I was really, really frustrated. So I really appreciate you guys turning over a new leaf today. You guys are participating. You guys have your videos on, except for a couple of you. So hopefully you'll turn them on this next time we go in there. But you guys are doing a lot better today, and I really appreciate that. Because the thing is when I think you're giving up, it makes me want to give up. hard for me to teach and be with you wholly when I think that you've given up. I just want to give up. So thank you for engaging today. All right, so we're going to do a problem with the E number now and see how that goes. So I'd like to do problem number 40. So you guys are going to do problem number 40. And I'm going to see you guys back here at 42, 45, 47, 11:47. So I'll see you back here at 11:47. All right, we're back. So you're going to look at the parent, which is the most basic graph, e to the x, and you're going to get those points. So if you put in a 0, e to the 0 is 1. If you put in a 1, you get e to the 1, 2.7. The transfer, okay, so e is exponential growth. And it's going to be what? What's the transformation, guys?
Left one, down one.
Thank you. Left one, down one. Thanks, Jerry. All right. So we go -1 and 0. -1 would be a 0. These guys stay the same. And now down 1 means subtract 1. And with this, you have 2.7 minus 1.0, which is 1.7 again, right? Did I do that right or no?
Yeah.
Yeah.
Asymptote over here.
Y equals -1.
Right, because k is equal to -1. Good, Andres. All right, so now we're going to graph this. So we have y equals 0 for our parent. We have 0 up 1 and right 1 up 2.7, which is 2 7/10, which is about 3. So 1 and up about 3. We're going to draw our growth. Okay, you ready? What's the domain?
-infinity to infinity.
That's right. And the range?
0 to infinity.
Right. Good, Jerry. All right, now we go to graph the parent, the new graph. We have an asymptote at y equals -1. And we're graphing the points. Left 1, 0, don't look at the black graph. And 0, 1 7/10, which is about 2. So you draw this graph along the asymptote. All right. I don't know why I drew arrows there. What's the domain and range, guys, for the new graph?
-infinity to infinity.
And?
-1 to infinity.
Right. All right. So I guess this is too easy now, right? So let's do another problem. Let's do problem number 49. Okay, so we're moving up here. So we're going to do problem number 49. And it's 11:51 I'm gonna see you at 11:57. All right? See you back at 11:57. Okay. All right, what problem? I erased the problem. What problem did you guys do? 49?
Yeah.
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 So 49, they're giving you f of x is the parent, so that's the parent. And then they're giving you g of x is times the parent. So that's a vertical compression by 1/3. So what are they saying? They're saying graph the functions and graph and give the equations for the asymptote. All right, so here we go. So if I were you, I would just do what we did before. This is exponential growth. The parent is 3 to the x. Compression by 1/3. Multiply the y by 1/3. So when you multiply y by 1/3, you get 1/3. And when you multiply 3 by 1/3, you get 1, right? Because when you're multiplying fractions, you can cross cancel. Can you guys see that? Is that what you guys got? You guys there?
I got that.
Okay. So this asymptote was y equals 0, and so is this one because k is 0, and they just want us to graph and state the domain. So the parent is y equals 0, 0 up 1, right 1 up 3. So the domain is all real numbers, and the range is 0 up forever. The asymptote on the new graph is the same because k is 0. So we have 0 up 1 out of 3 parts. So 1 out of 3 parts would be there. And right 1 up 1. Now, doesn't that look like it was vertically compressed? Like if I take my hands and push the graph down, does it look like the orange? Was vertically compressed. Okay, what's the domain and range? Same. And same for that. Okay, now what we haven't done any exponential decays. Now, remember that growth goes up, and if this is a proper fraction, the graph is going to go down. So let me erase this. The E numbers are never going to look like decay. I mean, they could be reflected and stuff, but they're not going to move the asymptote or look like it's falling. All right, so do me a favor, look at number 51. It says that we have this, and it says g of x is 1/2 to the x minus 1, that's the parent, then minus 1, and then 1/2 to the x minus 1 plus 1. So this, when that's a proper fraction, that's the parent, the graph is going to fall. So now instead of the graph going up, the graph is going to fall. That's decay. Now look over here. This is the parent that something's being done with an H and a K. So I want you to do this problem. So you're going to do 51. And we're going to be back before class ends. It's 12:03. So you're going to be back at 12:08. So you're coming back at 12:08. And as you're doing these graphs, try to hold your graph up so your partner can see what it is you're doing. And I'll see you back here at 12:08. All right. So I already wrote some of this stuff up here. It's out of the way. All right, so here's your parent points in the asymptote. Here's your new points when you add 1. This would be 1.5. So if you notice, this is right 1 up 1/2, and the graph is falling. That's decay. So the graph should be falling. And now you have a new asymptote at y equals 1. You're graphing the point 1 up 2 and right 2 up 1.5. So this one is also falling, and it's falling along the asymptote. So the first one, the domain is forever left and right. The range is up from 0. And the orange one, the domain is forever left and right. And the range is up from 1 up forever. All right, so when is this assignment due?
Today.
Okay, so you're going to do it now that you know how to do it, right? You're going to do it all. And great job today, okay? I hope you have a great day. And I'll see you in class next time. All right? Good job today.